Welcome back to the Aptos developer series. Today we're going to take a look at the Move programming language, which is the backbone of Aptos blockchain development. Let's start things off by exploring Move's core design principles. The creators of Move had three primary goals in mind: safety, expressiveness, and verifiability. Now you might be thinking, sure, that sounds great, but what does it actually mean in development? Well, let's break it down. Safety in Move goes beyond just preventing runtime errors. It's about creating a language that makes it incredibly difficult to write code that could compromise the security of digital assets. Imagine a programming language that actively tries to prevent you from accidentally duplicating or destroying tokens. Expressiveness is all about giving developers the tools they need to write complex smart contracts. Move aims to make it intuitive to represent and manipulate digital assets, which is crucial for blockchain applications. When we talk about verifiability, Move is designed to work hand in hand with formal verification tools. This means you can mathematically prove that your code behaves correctly under all possible scenarios. It's like having a superpowered debugging tool that can catch errors before they even happen. Let's get started with some Move syntax. We'll go with the basic data types and then onto some more complex structures. In Move, like many programming languages, we have primitive types and composite types. Let's look at the integer types. U8 can store values from 0 to 255, while U64 can store much larger values. And U128 is for even bigger numbers. The U stands for unsigned, meaning these can only store positive numbers. The number after U indicates how many bits are used to store the value. The address type in Move is particularly important as it's used to identify accounts and store resources. Think of this as a unique identifier on the blockchain, similar to an Ethereum address but with a different format. Addresses are 128-bit values in Move, and as you can see, Move provides a range of integer types, booleans, and a special address type. If you're coming from Solidity, you might notice that Move has fewer integer types, which actually simplifies things a bit. Vectors in Move are homogeneous, meaning all elements must be of the same type. This might seem limiting at first, but it actually helps prevent a whole lot of errors related to type mismatches. Structs in Move are more than just data containers. They can represent resources, which are a fundamental concept in Move's type system. Here's where Move starts to show its uniqueness. Let's look at a resource. In this example, token is a resource struct. It can only be created by the createToken function and destroyed by the destroyToken function. This level of control over creation and destruction is a key feature of Move's resource-oriented programming model. If you're coming from Rust, you might see some similarities in how Move handles ownership and borrowing. And if you're a Solidity developer, you'll find that Move's approach to representing assets as language-level constructs, which are resources, is a game changer compared to Solidity's more manual approach. The key takeaway for now is that Move's type system and syntax are designed from the ground up to make blockchain programming safer and more intuitive. Let's start with a simple function declaration. This transfer function is marked as public, meaning it can be called from other modules. The ampersand signer type is unique to Move. It represents the account that signed the transaction, providing a layer of authentication. Move also has a special type of function called an entry function. These can be called directly as transactions. Entry functions are crucial for interacting with your module from outside the blockchain. Now let's look at some control structures. Move's if-else statements and loops feel similar if you've used other languages. Notice that Move doesn't have a return function. The last expression in a function block is implicitly returned. This leads to more concise code once you get used to it. Error handling in Move is straightforward but powerful. Instead of try-catch blocks, Move uses the abort statement. The assert macro is a common pattern in Move. If the condition is false, the transaction aborts with the specified error code. The fundamental unit of code organization in Move is the module. In this code, we're creating a module at address 0x1 called basic_fa. The first few lines are importing necessary components. We're bringing in fungible asset framework, which gives us tools like mintref for minting, transferref for transfers, and other essential structs. We're also importing the object framework for creating named objects and primary fungible store for managing our FA tokens. Also, the module defines an FA struct and functions to create, mint, and query balances for FA tokens. It uses the Aptos FA standard for handling metadata and the fungible asset store. To use this module in another module or script, you would import it like this. Notice how the first line, use 0x1 basic FA, is bringing in our entire module we just created. Now let's talk about the difference between modules and scripts. Modules are reusable building blocks of your application stored on the blockchain. Scripts, on the other hand, are like one-time use transaction code. Here's an example of a script. The script creates and mints fungible assets when executed as a transaction. It uses the FA standard, replacing the old coin model for better customizability and standardization. Specifically in these lines, we're getting the mint reference and then using it to mint new tokens. In Move, resources are not just data structures, they're a fundamental part of the type system. Resources are special types that can't be copied or implicitly discarded. This might sound restrictive at first, but it's actually a powerful feature for representing digital assets securely. Let's look at a simple example using the FA standard. In this code, createFA function creates a new FA token through a multi-step process. First, it creates a named object using the admin signer, then it sets up the fungible asset with its core properties using primary fungible store. Finally, it generates a mint reference and uses that to mint the initial tokens with the specified value. Each step ensures proper initialization and security of the token. The transferFA function shows how assets are transferred securely between accounts using the FA system. It does this by first getting the metadata of the token from the sender's address, then safely withdrawing the specified amount from the sender's account, and finally depositing it into the recipient's account. The acquires fungible asset keyword ensures that the function has the necessary permissions to handle these assets. Resources like FA tokens can't be copied or discarded, ensuring that they are securely owned by one account at a time, perfectly mapping to how we think about digital assets. Let's talk about Move's type system and safety features. Move uses a linear type system, which means each value can be used exactly once. This is crucial for preventing double spending and other common blockchain vulnerabilities. Move also has ability modifiers that control what can be done with a type. The copy ability allows a type to be copied, drop allows it to be discarded, stored allows it to be saved in global storage, and key allows it to be used as a key in global storage. These ability modifiers give you fine-grained control over how your types can be used, adding another layer of safety to your code. But Move doesn't stop there. It also includes a built-in verifier that checks your code for safety violations before it's even executed. This verifier ensures that resources are always handled correctly, preventing many common smart contract vulnerabilities at compile time. Here's an example of how the verifier might catch an error. The verifier would catch this error because the token resource is neither moved nor destroyed within the function, which violates Move's resource handling rules. To wrap up, let's recap the key features of Move we've covered. Resource-oriented programming for secure asset management, linear type system to prevent double spending and asset loss, ability modifiers for fine-grained control over type behavior, built-in verifier for additional compile time safety checks. These features make Move a powerful language for blockchain development, enabling you to write secure, expressive code that closely models real-world assets and interactions. In the next video, we're going to move on to some advanced Move concepts, so I'll see you in the next video.